Alright, so this is now the last lesson on environmental change. This is lesson 5. We're going to look at the future of our planets and the scenarios that were made. The UN Intergovernmental Panel on Climate Change has made some climate change models, which are based on several scenarios, ignore that N, of emissions over the next 100 years. Then they put them into computers, and so for example, NASA worked on this quite a bit. Computer models which will predict temperatures, so the temperatures on land, also the sea temperature, the temperature through the water column. They predict on these computer models precipitation, what the precipitation will be like in the next 50 or 100 years, and of course snow coverage, ice coverage, etc., which all has a very important role in the albedo effect. I'm going to start off my lesson because I'm going to be talking about these computer models. So I would like you to go to this YouTube video and watch a 5-minute presentation about NASA and the predictions that they made. Now that everybody's finished the video, we'll continue the presentation. So almost the rest of the presentation will be based on that video we saw, but the video goes by quite quickly, and we'd like to go point by point about what we just saw. But I think it's very nice to see a visual representation, and then now we'll go a little bit slower. So as you saw, they showed one scenario that they modeled, and in this model, this is somebody's. I hate this. Yeah, can somebody put the earphones on? Anyway, uh, they have different scenarios. A1, they have 3 different scenarios. A2, B1, B2, and then IS92. Then they have subdivisions of these scenarios. So as you can tell, the red ones are the A1. So an A1 is basically a scenario where there's economic growth, very high economic growth, but eventually people stop emitting CO2, methane, N2O, and SO2. These are the greenhouse gases. And in around 2050, the emissions in A1T and A1F go down. In A2, the emissions on all 3 of the counts go up, but then eventually SO2 goes down. B1 is the most positive scenario on all 4 in general, because emissions only go up slightly and then go down. So in this scenario, there are lots of policy changes to stop emissions of greenhouse gases. B2 has a moderate increase of emissions, and the last one has sometimes a larger increase. So you see on the x-axis of all of these the year and how much CO2 is emitted in each year. Yeah. So first we looked at how much is emitted, and then when we look at the buildup. So if you emit CO2 or methane throughout those years, how is it built up, or is it broken down, etc. So if we look at the CO2 concentrations versus the emissions, in all of the scenarios, is CO2 concentration goes up. Sometimes slightly in the more sunny, let's say, more positive scenarios, and in the A scenarios, especially A1F, the concentration of CO2 goes up dramatically. This is a more pessimistic scenario. The concentration of methane is only expected to rise on some of the predictions, and in other predictions, methane goes down. Can anybody give me a reason why methane concentrations would go down around 2050? Huh? Well, in this scenario, the methane is combusted. So methane is a combustible energy. So it can be combusted into CO2, which isn't so positive. So in these scenarios, that's why the CO2 levels rise because the methane is turning into CO2, and we also have the water vapor. If we look at these concentrations then compared to so in the next 100 years, and all of these scenarios, so we're still working with the same scenarios, these are dramatically higher than not only what we've seen in the past 50 years, but if you compare it to the average uh, glacial, interglacial stages, so that means everything before humans started mass producing and scouring the planet, the concentrations were pretty stable. You have, of course, some variation, but the variation is seen to go up dramatically. In all the scenarios, even the most sunny, forward-thinking scenarios, the concentrations are expected to go up quite a bit. Because of this, surface temperatures are also expected to increase over the next 100 years, and this increase goes from, on a lower scenario, approximately 1 degree Celsius, and in the most pessimistic scenarios, this would be about 4.2, 4.3 degrees Celsius. And they've developed models that say if the if it was here, there could be an error value. Yeah, so the model predicts the temperature to be 4.2, but there is, of course, an error associated with these predictions. So it could be as high as like 5.7, 5.8. And if you see since 1750, the temperature increase has only been about 1. This means that this increase that we're expecting in the next 100 years is very dramatic indeed, well beyond any climate variation we've seen in the past. And this is the most optimistic scenario. It still goes up to at least 2 degrees. Yeah, so now we've looked at the temperatures on the on the whole, and now it's going to how is it going to affect the different biospheres or atmosphere, etc., on our planet. So if you take the most optimistic, only a 1.8 degree change, um, and again for the other one it's 4 degree change, but also go up to 6.4. What this means on the future climate is that the surface temperatures will raise dramatically. If the surface it raises dramatically, there is, of course, it depends on where you are on the planet. It's not always going to be the same. Um, so if we look at different parts of the planet, it's expected to be greatest over land, and also at the most high, that's in altitude, and the most northern latitudes. So this follows the trend that we've seen in the last over the last 50 to 100 years. The further north you go, and the higher you go, the more the weather has increased. The temperature has increased, and it increases the least over the southern ocean and parts of the North Atlantic Ocean. So you see here in the southern part of along the southern part of South America, it has the least increase in temperature, and also right here in the North Atlantic. However, uh, there are very large increases in Northern Europe, North America, and Central South America, because of course the Andes. Projection of the future. So precipitation will also increase. If the temperature increases, then of course more water will evaporate, and what is expected in the very far north of the most pessimistic models, an increase of 20% more rainfall. This rainfall, if you remember in the video that you just watched, there was also the effect of more rainfall along the coast, the western coast of South America. Um, and partly this is due to the increase in the, what's that effect called in South America? Every few years, it's called the El Nino. El Nino. So yeah, there's an El Nino effect, which will also be increased in South America. There is now increasing confidence in these projected scales. We've now, when I say we, I haven't actually done it. When I say we, I meant humanity and science in general. So that includes you when I say we. So the people who work on the models have this these have been working on them for 20 years, with increasing more data and faster computers. They've been able to project far into the future, and and they expect also extremes in ice. And this was something that they didn't take into account 10 years ago. We thought that the ice would melt at a steady rate, but actually, the more it warms up, the faster the ice is melting. So, with happening to the ice, the snow cover is projected to contract, which meaning getting smaller. So, where there is snow, it will get smaller in area. Widespread increase in thaw depth for permafrost regions. Do you guys know what permafrost regions are? Where's the permafrost on our planet? Yeah, so the far north of Canada, but also in Russia, Siberia, for example, there's a permafrost. That means the ground is permanently frozen throughout the year. So places with snow are supposed to be, there are going to be less places with snow, and the places that are frozen will become less and less frozen. Sea ice is projected to shrink in both the Arctic and Antarctic. So, and that's the North Pole and the South Pole. And in some projections, expect the late summer sea ice to disappear almost entirely or entirely by the later part or the latter part of the 21st century. So that means well, we might not be around then. So in about 70 years, the Arctic polar ice sheet will almost completely disappear in the summer ice. It's very, very likely that there will be hot extremes, so more heat waves and heavy precipitational events will happen. So there will be more extremes of heat and more monsoons, more hurricanes, etc. A lot more precipitation. So that tropical cyclones will increase not only in the number that are forming, but also in intensity. Oh, sorry. This says that there's less confidence in the decrease of total number. Yeah, so that they've been using that as a negative reinforcement. So they're not confident that it will increase, and they are confident that it will be more intense. Then there will also be more tropical storms, uh, bringing changes in wind patterns, precipitation, and temperature. So, what is now a dry climate may turn into a wet climate. It is also very likely that the circulation of the Atlantic Ocean, the Atlantic Ocean has a certain pattern where it mixes. Yeah, is there a question over there? No? Okay, just enjoying yourselves. So the pattern within the Atlantic Ocean, subsurface ocean patterns are expected to change, and the temperatures therefore are expected to increase. Okay, just there has been a. Okay, no comments. We'll comment on this after. There was a big shout here. People are very happy. Anyway, because of these changes in the pattern of the flow of the water underneath the surface of the ocean, the Atlantic region itself will, the water itself will warm up, which will then causes much more rain. And that's why in the next, let's say in over 100 years, uh, you, if you live in the Netherlands, you will already think it's rainy, but they expect increase of 20% because not only is the water warming up, but because it's warming up, it's mixing differently, and this different mixing causes a double effect on the precipitation of rain, of water, which is called rain, of course. Yeah, and this is also associated with projected increases of greenhouse gases, of course, an enhanced greenhouse effect. Now, what about the climate? The warming in sea levels, of course, will be could possibly stabilize if even if so. In other words, even if we stop, even if everybody stops driving a car in the entire world, and we only use renewable energy like windmills or solar energy or biofuels. Temperature is still, that means that's therefore the greenhouse gases stabilize. That's what they mean. I mean here by this line. The temperatures will still increase to 1.9, and I think I read an article recently that said that the 2-degree scenario is no longer reachable. These are based on, as I said, the Intergovernmental Panel on Climate Change, and this was done like 10 years ago. And now they are reviewing their data and their scenarios, and the optimistic scenario is now seen as impossible, uh, the most optimistic. So there you go. So even if it's stabilized, which as I'm saying doesn't seem to be the case in the near future, uh, the Greenland ice sheet, which is one of the largest, if not other than the North and South Pole, it is the largest ice sheet, will completely melt. And just the melting of the Greenland ice sheet would raise the sea level by 7 meters. Yeah, which for people living here in the Netherlands is yeah, 7 meters. I think most of the country is under a third of the country is should be underwater as it is, and if the ocean levels were to increase by 7 meters, that would basically mean that the rest of the Netherlands, which is only 4 meters above water, sea level, would be below. Well, there you go, Moraika. Congratulations. You'll probably be on the ocean. Her hometown will be safe. Limburg Beach, yeah, exactly. Um, and this is so 7 meters in comparison to 125,000 years ago, yeah. So of course the sea levels have risen and fallen throughout the history of our planet in the last billions of years that we've had water on our planet, but never 7 meters. It's been a meter, plus or minus throughout the entire history, and now they're predicting a 7 meter increase. Not so optimistic, yeah. This is also has an economic cost. We're not going to go too much into the economics. This is not a course on economics, but this economic impact, of course, will be quite large. And this is in 1,000 million US dollars, which is a billion in English. American English, it's a milliard in UK English, but that's 1,000 million US dollars. And since this is how much natural disasters have uh, uh, cost in the last few years, yeah. So we see a much higher increase going from approximately 5 billion, and this is corrected for inflation. Yeah, that's why it says here global costs of extreme weather events inflation adjusted. That means it's adjusted to what the dollar is now. Yeah, so obviously in the 1900s and the 1800s the dollar wasn't worth as much it is now. So this is adjusted for inflation. We've gone from approximately 5 billion annually for extreme weather to 40 billion annually. And that's just a small little change here, and we're expecting it to go much higher. Yeah, so if we go along this same exponential growth in extreme weather events, which has two parts. One is, of course, the fact that the weather is getting more intense, but also we're increasing the population of the Earth, and people are getting close, moving closer to areas of extreme weather. So it's double. That's why it's very exponential. We can easily predict hundreds of billions of dollars annually in the not too distant future. Yeah, nice, huh? Not so nice, no. Who's going to pay for all of that? We are, of course. It's going to be tax money. Uh, there you go. So why worry about the climate? Well, we've now seen the economic impact is an obvious reason. If this little increase here, just from this point to this point, has seen an increase from 5 million to, what was it, 5 billion to 20 billion. Can you imagine if the temperature increases go up in the next 100 years as it's expected, what these prices going to be? This is an increase of 10 million, 10 billion, 20, 30, 40, 50, 60, I mean hundreds of billions of dollars annually. Oh, that's a double sheet. Okay, so the last time we looked at the increase just over 50 years, and this is the increase to 2080, and we see here a 6-degree increase, a 5 to 6-degree increase for all of Eastern Europe, so Russia, Canada. We expect the entire northern polar region to go up at least 6 degrees, if not more. And this is the more optimistic one. And the less optimistic sees this expansion of 6 degrees or more temperature increase for all of North America, most of Europe, almost all of Asia, and Africa. So if you know where this is the northern Africa, the Sahara, the Western Sahara, and the Sahara as total is expected to actually increase 5 degrees. Sorry, I need to take a small sip of water. So, pathways of stabilizing. How can we stop this? Well, stopping emitting the the greenhouse gases would be a good thing. Even if we were to, that's where these, like I said, the scenarios were built on. In some of the scenarios, they expect the emissions to go down, and how? We invent new technologies. We have more strict controls on policy, and the emissions go down. But even if the emissions go down, the concentrations can stabilize but still go up. And even if the emissions stop and we bring them back to low levels, the stabilization is still at such an extent that the temperature changes won't stabilize for another 200 years. Yeah, so we stop emissions before 2100. At around 2100, therefore, the concentrations in the atmosphere stabilize. However, that still means the greenhouse effect will increase the temperatures until 200 years after that. Yeah, so even if we were to completely go to zero tomorrow, the effects will still be seen for another 100 years, and then the temperature change will stabilize for a couple hundred years after that. So that's what the models say, and so that's relative to baseline now. The probability of increase and 450 parts per million, 550, 650, and 750. This is a very large increase. And here's a nice map of precipitation changes until 2080, where blue being the highest increases. Oddly enough, places that are dry will stay dry or even become drier. Yeah. So expect more droughts. Here's a regional precipitation map. So now you can look at different parts. The Mediterranean area will see a decrease in precipitation, which is already a rather dry region for Europe. It's a dryish region. The Northern Europe will see a increase in rain. Most or all of Asia will see increases in rain. Australia, which Australia is a pretty dry country, especially Eastern Australia. If you watch the news, you know that they have a lot of fires in the east because of drought conditions. This will see even more drought conditions. For people in South America, this is kind of stable. They don't see huge changes, but in North America and in North America, we expect increases, and in Central America, so around Guatemala, etc., uh, there will be decreases in rain, which of course will have consequences for the rainforest there. In the Arctic summer, as I mentioned, we see now the North Pole. This is what it looks like now, which is already a decrease from 50 years ago, a significant decrease. But we expect by 2080 to be very little ice left over. Not so nice for the ecosystem there, but of course it also increases the sea levels. As we see here, the sea level rises in meters, approximately a 1 meter rise. Imagine if 1 meter, if exactly, Limburg would be the beach in the Netherlands. But not only the Netherlands, you can see Florida and the United States would be gone. Uh, Lots of Western Europe would be underwater. Almost every single island country like Tuvalu or the smaller Northern Pacific islands will be gone. Yeah. Huh? The Maldives absolutely be gone. That's in the Indian Ocean, the Maldives. The Maldives, which always has been like one of my top destinations to go on vacation. I've never been there. I guess I have to start planning that trip soon, because the Maldives are one of the most pristine islands in the world, and they're only a few centimeters above sea level, so they'd be completely covered over in water. There's no dike in the world that will keep out a meter of water. It'll just seep through the sand, come through the sand, and you can't stop the ocean. Don't even try. Um, and here I got the scenarios of emissions. Yeah, by 2010. This is what we have now and what we're emitting, and this is what the scenarios are based on. So that instead of having in coal, right now we're emitting uh, that's GT is gigatons of carbon. So this is measured in how much carbon is, so CO2, how much carbon, gigatons of carbon are being emitted right now by coal, gas, or oil. Oil meaning, our cars. Uh, Gas is also used quite a lot, and coal. So much of the world still relies on old-fashioned coal. And in these scenarios, uh, we see a dramatic decrease in that. So as a summary, it's a little bit confusing. I'm sorry I actually got rid of this. I used some old sheets to make it. But in summary, the global average temperatures and sea levels have been projected to rise under all of the IPCC, the Intergovernmental Panel on Climate Change scenarios. There were 7 or 8 scenarios, and even the most optimistic, we expect about a 1.4 increase in temperature, and in the more pessimistic scenarios, a 5.8 degree Celsius change in the next 100 years, or 90 years even. Precipitation will generally increase, especially in Northern Europe and North America, and in some other regions like the west coast of South America. In general, but this does vary. So the Sahara will stay approximately the same. Mediterranean region in general, we don't expect more rain, but then of course Asia a lot more rain. Extreme events, so more extreme events, and the extreme events will become even more extreme. El Nino, there will be a less change in amplitude, but they'll be more severe. There is expected to have an increase in monsoons, and monsoons are always in Asia. They call them typhoons or hurricanes in other places. Monsoon is in Asia, so an increase in the summer precipitation of the monsoons. The thermocline circulation weakens, but it will not shut down. This is the talking about the air patterns around our planet. The snow and ice cover, we see dramatic decreases. Uh, the Antarctic may gain some mass, but Iceland will lose all of its ice. The North Pole will almost disappear. Sea levels we'll expect in the next 100 years to increase up to towards a meter, so 88 centimeters. And this is due to thermal expansion, meaning the molecules of the water will increase. So people think that because the ice is melting, that there's more water in the ocean, which is maybe 20% of the increase, but actually 80% of that increase is through thermal expansion of water. So the warmer water gets, the more it expands. And anthropogenic climate change will persist for many centuries, even if we were to stop everything right now. If we no longer had any electricity or energy on our planet produced from coal, oil, or gas, the anthropogenic change will persist for hundreds of years. There's no stopping that. Okay, that's the end of this lecture. Thank you for watching. We are actually finished with the course Environmental Change, and thank you for watching.